In this video, we're going to talk about multi-access channels, the protocols that are being applied to them, their capacity, and generally how they work. Before we get into details, I want you to know that without multi-access channels, we could not communicate the way we do today. As a matter of fact, we could not even send photos, perform voice calls with each other because we couldn't do it at the same time. One reason why in today's world it's so easy to send information to each other, to talk to each other, to send photos, to upload photos, to transmit all this kind of information is because we are a part of a multi-access channel. We're actually a part of multiple multi-access channels. So, what is finally a multi-access channel? A multi access channel is actually a network that allows a big number of transmitters or senders to send information or generally communicate with a common receiver. So, the most basic one I can think of and give you an example is actually the Ethernet you have at home. A lot of computers are connected to it. This is a cabled multi-access channel. But you can also have wireless ones like a multi-access channel of a satellite communicating with multiple antennas, or a multi-access channel between some electronic devices, mobile phone computer, and an antenna. To understand how multi-access channels work in real life, let me give you the example of a WhatsApp call. What's happening when you're calling someone on WhatsApp? So your voice is actually an audio signal. Audio signal is turned by your phone into a digital signal. Your phone emits radio signals to the nearest antenna to your house. That antenna decodes the radio waves and sends the encrypted information through optic fabric to the mobile core network. So, what's happening there? The WhatsApp server decides at which antenna will send the encrypted information based on the IP of your friend. It sends the information to the closest antenna to your friend's house. It decodes the information and then it's sent to your friend. But thing is, you are not the only one sending radio waves to the antenna, to the base station that moment. There are multiple transmitters sending information. And this is what it means to be a part of a multi-access channel. At this point, you might be wondering how the base station, how the antenna is handling all this type of information without making any error, without sending signals to random receivers. For example, how does it do it at the same time without wrong demodulation, without mistakes? The answer is multi-axis access channels are coordinated by protocols. Protocols are like managers, they organize signals, where they will stand, where they will go, which path they will follow. They're just like traffic rulers. Traffic rulers are telling the cars where to go when there is traffic. Just like here, we have traffic of signals, and a protocol tells them where to go. There are many type of protocols, just like there are many forms of organizing something. The most common one is the FDMA protocol. So, according to this, the antenna gives a specific corresponding frequency to each transmitter. There are other type of protocols like TDMA that gives a specific slot to its transmitter, and the ALOHA, which is non-pre-scheduled protocol. Without protocols, there would be chaos. Without protocols, multi-access channels could not perform without any mistakes. And this is why it's very essential to know how they work. If we are about to study multi-access channel, it's very important to talk about the capacity of a Mac. I will first tell you what is the theoretical notion of Mac capacity, and after this, I will tell you what is the practical one we use every day, we use in everyday life. So, the capacity of a Mac is actually the total maximum data all users combined can transmit reliably to the receiver per second. What do I mean by reliably? Without any faults, without any delays, without mistakes. And what do I mean by all users combined together? Well, for this, we will have to use an example. Let's suppose that we have a multi-access channel with a capacity of 15 megabits per second, and we have five transmitters denoted to this multi-access channel. So each one of them can only use 10 megabits per second. Their information cannot exceed, their capacity cannot exceed those 10 megabits per second. If we had only one transmitter denoted to the channel, yeah, it could use those 50 megabits per second. But when we have various transmitters denoted to a channel, to find their capacity, we have to divide the MAC capacity by the number of the transmitters that we have. What happens in reality, however, is that you cannot use a multi access channel without applying a protocol to it because it will be a chaos. And protocols consume bytes, they consume space, they consume time. So, whenever you calculate the effective capacity of a multi-ax channel, you have to take into consideration that some portion of it will be used for the coordination and organization of the protocol. Now, let's give an example of how to find this effective capacity of the MAC. Let's suppose that the theoretical capacity of a multi-access channel is 100 megabytes per second, and we're using slotted ALOHA protocol to it with an efficiency of 0.36. To calculate the effective MAC capacity, we have to multiply 0.36 by the theoretical capacity, and that gives us 36 megabits per second. And that 36 megabytes per second will be used for the transmitters, will be divided fairly to the transmitters, not the theoretical capacity. To make it a little bit more engaging, we're going to solve a real life problem, just like we are engineers. So let's consider a multiple access channel that has a capacity of 100 megabits per second, to which end stations are connected, are denoted. A protocol is used over the channel for access control, which operates with efficiency zero point 0.3. The station uses the channel to send video. The video is recorded at a rate of 24 frames per second, and each frame consists of 1000 pixels. Each pixel has a value represented by 8 bytes. Question: what is the maximum number of stations that can be supported by the network? So I don't know if you noticed, but this problem is asking us to find, to design, basically, a multi-access channel based on some given characteristics of the transmitters. So it is giving us the capacity of the channel for sure, the protocol efficiency, and it tells you some information about the transmitters. If you understand what this type of information is, then you will be able to solve the problem and find the maximum number of the stations. So the information that it gives about the stations is actually how much space, how many bytes each one of them is able to transmit, because it tells you the video is recorded at the rate of 24 frames, 24 pictures per second. Each frame is 1000 pixels, and then it gives you the bytes of the pixels. So first thing you will do is to calculate the capacity of each station. This is very crucial for the problem. As we said before, the capacity of one single station, is given by the ratio of the effective MAC capacity divided by n. If you solve for n, you get this ratio, effective MAC capacity over capacity of one station. What is the effective MAC capacity? It's easy one. You multiply the efficiency of the protocol by the 100 megabytes, that is the capacity of the channel. Now let's decide about the video capacity. One video is 24 frames. What is the frame capacity? 1000 pixels multiplied by the 8 bytes. So if you want to calculate the capacity of one station, you have to multiply the frame capacity by 24, which is the total number of frames one station is emitting per second. And finally, uh, submitting this into the fraction to find 156 stations at maximum. So the maximum number of stations this multiple access channel with those specific characteristics can support is 156 stations. Now, if we found something that is less than that, you wouldn't have found the maximum stations that it can support. And if you find something that is more than this, then it would be wrong, because if you add more stations to this multiple access channel, it will break down and it will collapse.